Hello there guys, and welcome back to another epic inexorable maths video. In this video we're taking a look at part 3 of our quadratic / nonlinear simultaneous equations, okay? Now this question that I've got on the board is an absolute monster, okay? In fact, in the textbook that I got this out of, that I will not name for legal reasons, this is a two-parter. The first part is 3 to the power of x equals 9 to the power of y minus 1 equals this, and it tells you what this is, show it. And then they ask you to solve the simultaneous equation. But what you can do is you can substitute this top monstrosity for something much easier. In fact, it's a straight line equation, and then you can solve this much easier. I'm challenging you guys. We're not going to do the middle part. I'm not going to tell you what this is equal to. We're just going to solve it. So let's just solve it. So, okay, the first thing I want to say is substitution. It's initially quite unclear what you should be substituting for what, right? Like, it's not clear at all. But, and I really must stress, I don't want you to substitute anything at the moment because it's a mess. We're going to do something. We're going to do basically what part 1 of this question was asking us originally. We want to convert 3 to the x equals 9 to the y minus 1 into something that's much nicer. How do we do it, guys? Well, this is just something that you need to see. You need to observe a pattern with these questions, okay? 3 and 9 are related to each other exponentially because 9 is 3 to the power of 2. So what I'm going to say is 3 to the x equals 3 to the power of 2 to the power of y minus 1. Because 3 to the power of 2 is 9. So this is 3 to the x equals 9 to the power of y minus 1. So these are the same thing. But now I'm going to use the law that we can use, the index law, that when you have something to a power, and then it's in brackets, and those brackets are raised to another power, you can multiply these two powers together. So we can say 3 to the x is equal to 3 to the 2y minus 2, okay? So stick with me on this. Here's an example. 2 to the 3 to the power of 2 is 2 to the 6, right? Yeah? Because you do 3 times 2, yeah? So it's the same thing. We're doing the same thing. We're saying 3 to the x is equal to 3 to the 2 times y, 2 times minus 1. Okay, so it's like expanding out. So just to show you guys, just to be really clear, this is, we actually don't need brackets, this is 3 to the power of, and we're going to times the powers, yeah? So 2 times y minus 1, and we're going to expand that, which is 3 to the 2y minus 2. That's where I got 2y minus 2 from, okay? So I hope that that step is clear. We have this equation, 3 to the x equals 3 to the 2y minus 2. Now guys, you might remember from GCSE, if I raise 3 to the power of something to get 3 to the power of something else, because these bases are the same, this must mean that just x is equal to 2y minus 2, okay? The exponentials are the same, or they must be the same, because the bases are the same. 3 to the what, or 3 to the x equals 3 to the something else. Well, that thing, that other thing, they must be the same. X must be 2y minus 2 because they're both being raised to the power of 3, which is the same base, yeah? If I said to you like 2 to the 4 is equal to 2 to the x, you'd be like, x is 4, x is obviously 4. Well, yes, it's the same principle. It's the exact same principle. X and 2y minus 2 must be the same, okay? So if you are still with me, we're going to have the simultaneous equation. How shall I write it? I will actually rub this out. I'll rub it out, okay? This is now the simultaneous equation. X equals 2y minus 2. That's our first equation. This equation is the same thing as this equation. I know it doesn't look like it. This represents the same line, the same graph, the same everything. This represents the same thing that this does. So we're just substituting it, okay? So this is our first equation. Our second equation is x squared equals y squared plus 7. Now, guys, we can use substitution. We already have what x is equal to. It's given to us. So let's use x. X is equal to 2y minus 2, which means if we use the second equation, x squared equals y squared plus 7, we can do something absolutely glorious. We can substitute something in. We can substitute x, which is 2y minus 2, and that needs to be squared, doesn't it? Because this is x is 2y minus 2, but x squared. So we're going to square our 2y minus 2, hence this. And that's going to be equal to y squared plus 7, okay? Because it's still equal to this side. And then I'm going to come over here, and I'm going to expand this out. So again, using FOIL, but like just not writing it all out because that takes too long. We're going to have 4y squared. 2y times minus 2 is minus 4y. And we're going to minus another 4y because this is going to be outsides, and insides. This is the same thing, just try it if you want to. Try using FOIL. And that's equal to y squared plus 7, okay? Right, that's just a bunch of messy algebra. We've then got 4y squared. Actually, let's just let's simplify this, try and do it in one go. 4y squared on this side, y squared on this side. Let's take y squared away from both sides. 3y squared. That disappears. Actually, no, I'm going to keep it because otherwise it's going to get really confusing. So this y is gone, okay? Right, minus 4y is minus 8y. 4, I'm going to take 7 away. So I'm going to take 7 away from both sides. So I'm going to get minus 3, because this is 4 minus 7, which is minus 3. And that's equal to 0, because I already took that y squared away, okay? I hope that makes sense. If you want to, try it yourself, rearrange and whatnot, you will get this, okay? So now, you cannot divide all three of these things by 3 without it getting more messy than it is. So this is probably a time that warrants the quadratic formula. Now, just looking at it, you can use another method, but I'm just going to use the quadratic formula because it's much, much faster. So guys, go into a calculator, whip out the quadratic formula, and do what you've got to do. So I'm getting y equals 3 as one of my answers, and I'm getting y equals minus a third as the other answer. So that means that if you substitute either 3 or minus a third into this equation, it will indeed equal 0. Which means, guys, we already used the quadratic formula, we've solved for y. Now we want x. Luckily, we're already told what x is. X is 2y minus 2. So in a non-confusing way, hopefully, I'm going to come over here on the left-hand side and do this, okay? So I hope I'm still in the frame as well, by the way, guys. If I'm not, then that's a bit of a shame. So x is equal to 2y minus 2. But I'm going to say that y is 3, because we've already solved it. So it's 2 times 3 minus 2, which is 4, yeah, because it's 6 minus 2. X is also equal to 2 times negative a third minus 2, which is equal to minus 2/3, because this is here, minus 2, which is equal to minus 2/3 minus 6/3, because 2 is 6/3, which is equal to minus 8/3. Okay, minus 2/3 minus 6/3 is minus 8/3. So now, guys, this is the answer. X equals minus 8/3. Y equals, so what number did we use for this? We used minus a third. So y is equal to minus a third. And x equals 4. Y equals 3. Again, these are coordinate pairs. You cannot say that x is equal to minus 8/3, y is equal to 3. You can't do it. You must say this is a coordinate pair, this is a coordinate pair. They are separate things, okay? And again, just to be very clear what these numbers actually represent, if you were to substitute x as minus 8/3 and y as minus 1/3, Both of these equations, in fact, the equation, this is what we started with, right? 3 to the x, that looks nothing like a 3. 3 to the x equals 9 to the y minus 1. That was the equation we started with, remember? If you were to substitute x as minus 8/3, y as minus 1/3 into both of these, they would both be satisfied. If you were to substitute x as 4, y as 3 into either of these, they would also both be satisfied, okay? So there are two intersections on this graph, okay? So guys, by the way, and this appears to be some form of hyperbola, is that how you pronounce it? Something like that. Again, not even in the A-level, you don't need to worry about it. But I believe, guys, I might be totally messing this up. Let's just see if I can do it. So guys, I sort of tried to draw it. I think I really butchered it. I think I really, really badly butchered it. It's like, I will get up on Desmo's a screenshot of what it actually looks like if you guys are curious. But again, you do not need to draw it. You will never be asked to draw something like this in your A-level career, because it's not in the A-level. Those graphs are not in the A-level. Anyways, guys, thank you so much for watching. If you enjoyed this video, if you found it helpful, please let me know. Tell your friends all about Inexorable videos. Like and subscribe if you want to see more.